G'day. Welcome to another Toolbox Tech Talk. And you're probably wondering, what's happened to DJ Glenmo? Well, DJ Glenmo can't always be live on every Sunday, and so he sent the boss in. That's me, Glen Morris, General Manager of the Smart Energy Lab. And today I'm a bit excited because I've got a very smart person to interview today. It's Dr. Hao from Morlus, and we're going to learn a lot about lithium batteries, lithium cell technologies, and his company, Morlus.
Hello.
Hello.
Hello, Miss Norris. Great to see you.
Yes, it's great to see you too. So where are you joining us from?
I'm joining you from China in Shenzhen, the city in the south part of China, also considered as the Silicon Valley of China nowadays. And here's the headquarters of research of Morlus Company.
Wow, Shenzhen's amazing. I actually haven't been there since before it was built. 1982, I think, was the first time I got close to Shenzhen, which was really just duck farms back then.
Huh? You
It's
should
an
come
amazing
see this.
city.
Yeah, amazing city, indeed.
Yeah. So for the audience, maybe just tell us a bit about yourself and your company, Morlus.
Okay, great. Maybe I'll start for myself. I actually had my bachelor study in China, and then I went to Europe. I studied. I started to study lithium-ion batteries and all its related materials in France, in Amiens, in a lab called IRCS, which is considered really, I think, top tier research labs in the world for lithium-ion batteries, and supervised by Professor Charleston and Christian Musgrave. Um, After that, I had my PhD study with the Professor Peter Bruce in Oxford University. And after that, I graduated from there. I went back to China to join BYD. I spent quite a lot of years in BYD, and eventually I joined the Morlus. As for Morlus, Morlus is a very young company. It was founded in 2022, I think. With the founder of Morlus was previously the vice president of BYD Power Battery. He basically started all the BYD power battery business, and then from the first cell to eventually to build the gigafactory level for the world first LFP gigafactories. And then he resigned BYD for a while, and then started this company called Morlus. And I was as he was my first supervisor in the industry, and at some point he called me back. So that's how we started this company, and uh, that's the basic information about the company. Actually, the founder teams here in the company, they are all coming from BYD, and previously they were all very high level management and also at R&D persons from BYD. So the entire founding team got a lot of experiences in the battery industry. Um, and currently we started to form the batteries for energy storage, but actually now we develop quite a lot of business scenarios, including but not limited to vehicles and special application scenarios and maritime applications, and all sorts of places that need batteries to be electrified. So that's some basic information. I hope we can talk more in the coming session.
Yes, well, I think for my Australian audience, they're probably not very familiar with Morlus. So maybe I might just share your webpage and we talk a bit about the sort of products that Morlus produces.
Yes, great. Yeah.
So when we go to your homepage, the first thing that catches my eye is that not only do you do energy storage, but you also do these things like mobile vehicle charging solutions. Where did that come about?
Oh yeah, that's the idea comes from the shortage of the infrastructure for electric vehicles over here in China. Although that country and also the companies in China paid a lot of efforts to deploy the charging facilities over here, but still we have lots of shortage because every year we have lots of electric vehicles to be purchased, and then that is on the road. And in some of the places where you don't have enough charging cables and charging facilities, then this vehicles is something that satisfies people's demand for charging. And we start to work with one of tier one Chinese, I would say, automotive companies to have this idea to build up the entire completely new charging vehicles with them, and only not only with the batteries we have, but we're also thinking about to embed the artificial intelligence so that the charging vehicle can move by themselves to the place where it is needed for charge. And nowadays we've been
Oh,
deploying this in quite a lot of places in China. One of big city called Tianjin, which is the top five cities in China. Their bus fleet is using these charging vehicles to charge the entire fleet. And in
so
some parts, yes,
so does it work a bit like your robot vacuum cleaner, that it has a dock that it goes back to and charges up, and
uh,
then can go to the vehicle
yes,
and charge
yeah,
the vehicle?
exactly. In some of the stations, they can basically automatically goes back to the dock and the charge, and then come back to the place to recharge to refuel the bus fleet. But in other places, majority of stations they are operated by operated manually because still the artificial intelligence equipment is expensive compared with the fixed labor over there. So at this stage, it's basically I would say 30-70 ratio. Yeah.
Wow. I mean, I was pretty impressed with my last trip to China. I stayed in a hotel that had robot room service.
Yeah.
I think robots are finding lots of uses, and I think this is a great idea to solve the infrastructure problem for charging of EVs.
Yes, exactly. And also, it's solving problems the charging demand in the mining site as well. In north part of China, there are a lot of mining sites, and the majority of them now are switching to the from the fossil fuel to the electric vehicles, especially the trucks, to carry on those mines. But the problem with it is that they are far away from charging facilities, and then they need to be charged. And so we are taking this to there to run over there. So every day it can charge 6 or 7 times because the entire charging vehicle is capable to do really quick charge and discharge. So that serves the need of the area very well.
Oh, that's really interesting. Now,
Mhm.
let's start at the base, which is really the cell level. And you make your own cells,
Yes, we do make our own cells.
and that's where a lot of your development has been, isn't it, in cell
Yeah,
technology?
exactly.
So, tell me a bit about these prismatic cells. Their form factor is a bit interesting. The long, thin ones.
Hmm. Yeah, so there are some backstories over there. As you know, like nowadays you have like this 280 amp hour cell and also 314 amp hour cells. That was very popular, almost as a standard format for the energy storage markets. But all the way back, it is initially not designed for energy storage. It is designed for bus fleet. And to a certain point, and people are just taking this batteries into the energy storage devices, and then eventually it became a kind of like standard format. But intrinsically, it has some drawbacks for using for the energy storage, especially in the case scenarios that you need extremely long lives. This kind of cells can basically not sustain because the form factors. So from this point of view, when we started this company, we were thinking we need to design something unique, something that perfectly designed for the energy storage scenarios. So that's why we come up with this long battery blade cells. The idea is basically to utilize the form factors to have highest utilization rate of the volume at battery pack level, and also in the same time to make sure the battery cell within the chemistry and all the reactions and also all the mass migrations during its operation can be really homogeneous, and also the temperature distribution will be really homogeneous, so that it can make the energy storage batteries to be last very long. So that's the idea that came up, and then we did actually have quite a lot of engineering work and innovations inside, applied a lot of patents for that, and eventually it takes us about 6 months to develop the entire format and also the chemistry, and it rolled out after I think 1 year and a half of after the company was founded.
Now, I'm
Can
just looking at the C rating on these. I see that the prismatic cell, the LC01P, have a 1C charge, 1C discharge rating. What do you have to do to get those kind of performance characteristics out of a lithium uh, ferrophosphate battery?
Yes, I think it is not hard for a lot of people to claim like the cell have capability of 1C, but actually for likely to continuously charge and discharge in 1C and make sure that it has long life is the key and the difficult. And more difficult, more hard part is that when you are placing these cells in the battery pack, even if you can charge at 1C and discharge at 1C, the temperature differences and also temperature rise will be really dramatic. As for our format of cell, the temperature elevation and also the distribution will be relatively more modern compared with the others. So that is the advantage of these cells. So in order to achieve that, except the formats, well, what we did is actually at the cell level.
Right. Wow. Yeah, I guess heat is your enemy. So ways of reducing that and maintaining a high C rate is the secret to this performance cells. Um, let's look at some of the products that these get put into. So you put them into cell packs.
Uh-huh.
I noticed that you've got some there that have a 1C rating, some which are designed for really high energy density.
Yes.
Tell me a bit about these cell packs.
Yeah, the cell pack. So you know that in the energy storage scenarios, people are always trying to have high energy density per hectare, so that basically it can save a lot of capex. That's the idea. So we need a very high energy density, and then at the cell level, a lot of companies trying to basically to squeeze more energy matters within the cells. But that will, of course, bring a lot of drawbacks. One of them is basically short the lifetime of the cell. From our idea, it's completely different. It's just like the all the automotive industry is doing. Is that basically you increase energy density at the especially volumetric energy density at the cell level, and in the same time you increase the volumetric uh, utility rate of the entire battery pack at the system level, which means that you can squeeze more battery packs within a 20 feet containers that is standardized for energy storage nowadays. So from this point on, we specifically designed the cell dimensions and also the pack dimensions. And within, we use this blade cell to pack concept. So further increase the utilization rate of the volume. And we eventually reached about 76%, sorry, 67%. And eventually it reaches really high energy density for the entire system. So we can do about 4.2 megawatt hours at nowadays for the 20 feet containers. And in our next generation product, it will be even higher than 7 megawatt hours for 20 feet containers.
Wow, that's incredible energy density. 4 megawatt hours in a 20-foot container and more to come.
Yes, exactly.
Now, do you utilize liquid cooling in any of the cell packs?
Yes, we use liquid cooling. Uh, an interesting thing about this liquid cooling is that I think in the industry, if you're using the conventional cell format, the afterwards liquid cooling, if you're cycling at 0.5 C, the temperature rise it will be about 10 degrees Celsius. And then, sorry, the temperature difference within a battery pack will be 10 degrees Celsius. And if you're cycling at 1C, it will be even higher. Somewhere the temperature difference will be even higher than 15 degrees Celsius. But for our product with this liquid cooling, we have two-layer sandwich structure. The liquid cooling is placed in the middle, and with kind of a unique structure and also the unique feature of the cell. Eventually, we can reach about 3 degrees Celsius temperature difference at 0.5 C and 7 degrees Celsius temperature difference at the 1C continuous charge and discharge, which gives really good impact on the lifetime of the entire battery pack.
Why is a close temperature tolerance important?
Uh, yeah, the difference is actually coming from the efficiency of cooling. Although we're having almost the same kind of like cooling plate or and liquid cooling systems, It is the special format and then battery pack we designed, which utilize majority of the surfaces for the at the cell edge, basically to conduct the heat away by the cooling plate. So eventually, it gives really good cooling efficiency that gives very good, I would say, thermal performance for the battery pack.
Right. Now, these battery packs go into different solutions,
Yeah.
for instance, C&I energy. So you've also got uh, a full BESS system.
Yeah.
So it's got inverter and batteries. Is that right?
Yes, yes, and we even put it into the electric vehicles. For example, the heavy-duty trucks and the agricultural machineries that is using the pack nowadays. Yeah. So it is very robust design and it's used for lots of application scenarios. And nowadays we're also working with several companies, both in China and in Europe, to develop the maritime application based on this battery pack.
Right. So I'm just looking at this unit here. That's 352 kilowatt. Is that kilowatt hours? Yeah, kilowatt hours, I imagine it
Yeah,
would be the
yeah,
storage capacity.
yes, that is for
Yeah.
the DC cabinet. That is for international markets.
Right. And what's the PCS rating?
We don't have the PCS over there. I think the one is basically a DC block. So the customer over
Oh, I
here,
see.
they're purchasing the DC block and then basically integrate as an entire system at their site. The thing is that we noticed that there are quite a lot of companies that in the Europe or international market in international markets they would like to have the DC block rather than the entire solution because they have to be compliant with the regulations to get into the grid. The easy way is that they get DC block over here and they get their own AC suppliers in their own country or the region, which is very familiar with the regulations over there. That brings the most value for the project. So that's why we have this direct DC blocks supplied to the customers rather than an entire solution. But at the same time, we will also have this entire solution because some of the small business.
That's really cool. Now, maybe just a little bit of diving a bit more about you. I was going to stop sharing that screen now. So, what got you interested in energy storage? How did you end up in your role at Morlus?
Yeah. They when I was back to I think 3 4 years before when I was still in BYD. That time I was initially I worked a lot with the electric vehicles, and from time to time we have projects for the energy storage as well. And I noticed that there's a global trend of energy shifting or energy transition from fossil fuel to the electricity. And the battery storage for sure is something very vital for the transition. So I see not only the electric vehicle scenarios will have great demand for the batteries, but also the energy storage scenarios will have such an enormous demand for the batteries. So that's why I think there will be a huge market and huge potentials over there. At that time, I think one of the I would say one of the misunderstandings that a lot of people think the batteries for energy storage is quite simple, but actually the batteries for energy storage isn't that simple. You have to basically uh, it's not a balance, it's a game of extreme. So I think the batteries for electric vehicles are a game of balance. You need to balance a lot of different properties. But for the batteries for energy storage, you have to do everything in extreme way. You need extreme long life cycle, you need extreme low cost, and you have to have extreme because a vehicle is basically sustaining and people are just using for like 10, let's say 5 to 10 years for most of the period of time and about 15 not a lot of people are using an electric vehicle for 15 or 20 years nowadays. But for the energy storage devices or asset, I would say it is more like infrastructure asset. So you are talking about lifetime about 15 or 20 years, and with low cost initially. So that means you need to make everything in an extreme way to make sure it is robust for 20 years, and then it is still price attractive for the customer to buy. So I think that is very challenging and in the same time, we have great potential over there. So that's why at some of the point, I decided, okay, I need to do something about energy storage. Um,
Oh, cool.
yeah,
Hey, I'm really impressed by the you're talking about 15 and 20-year life, and when I see 11,000 cycle life, that's really
yeah,
industry leading. I mean, mostly I'm seeing 4,000 to 6,000 cycles.
yes,
Um, yeah,
that's true. We did quite a lot of
that's
engineering work on that. So basically, the battery itself is not only about chemistry and materials; it's also about engineering design. It is I would say, a complex combination of both electrochemistry, materials, and also structural, and also the force. There's a very complicated interactions between all these elements. We basically developed a understanding between these kind of relations, like the force and electrochemistry and mass migration within the battery cells. So eventually, with picking the right materials and has the right structure at the electroside and also the right design at the battery cell level, and eventually we reach this really long lifetime.
well, things are developing very fast in the energy storage world,
Yeah.
and some of those things that you just mentioned, price, energy density, everything's getting better and better.
Mhm.
So, just a bit of crystal ball gazing. What do you see the most promising trends in energy storage today? Where are the trends going?
Yeah, the trends in any storage scenario nowadays is basically, I would say first is it's really competitive, and different companies are coming with different technologies and understanding of the battery itself, and also more of the innovation is actually at the system level. So I would say it's a very competitive directions. And among these directions, I think for the battery point of view, people are really looking for uh, I mean, R&D directions or the technologies that can basically make batteries last longer and also in the same time be safer. I think that's the most primary and crucial demand that the customers have has passed by to us. So I think that's the direction and trend for an R&D and also product development in the industry. And alternatively, people are also looking for new chemistries. For example, people are looking for whether or not sodium-ion batteries can basically have better advantage. I mean, to have advantage in the cost, so that the energy storage can basically be massive deployed. And also, there are new chemistries coming up, like a lot of Floyd battery systems uh, as well. So I think there are quite a new ideas coming up in this direction, but most mature directions is still lithium-ion batteries. And within this direction, it is the lifetime and also the cost and the quality of the battery cells and safety which comes. Yeah.
I imagine a lot of the developments that you've made for LFP
Yeah.
technology could move on to others. I mean, sodium ion looks very similar. Um, do you see that as a growth area? Sodium ion batteries.
I think uh, I personally have some understandings on, or I would say, thinkings about sodium ions, and I think majority of people are thinking sodium ion as kind of like alternative to replace the lithium ion. But from my point of view, it won't be to replace the other game. It will be something as a supplement to the lithium ion batteries because the characters of two batteries is actually quite unique, and basically they can cover their own markets and demands, but they cannot basically. I think the overlapping of these two systems is quite small, so you cannot basically say one will replace the other. Sodium ion has the great advantage in the actually in the rate or in the power in its power performance and also in the temperature tolerance. You basically can cycle the sodium-ion batteries in a really quick, in a really high C rate at a extreme temperature. For example, at low degree, minus 10 or 20 degrees Celsius. But for lithium-ion, that is relatively difficult to do. Um, so that I think the sodium ion will have unique markets to suit for. And in the same time, if the sodium ion compete with lithium ion in terms of the price or the cost of the batteries. One of the challenges that sodium ions basically have almost half of the energy density of lithium ion. So in terms of the price per watt hour or price per kilowatt hour point of view, it is not compatible even nowadays, and it still needs to have a long way to go. But good thing is that it is kind of like a leverage of the lithium price. When the lithium price goes above, I think about 100,000 RMB, then the sodium ion, the entire system will be cost effective comparably with the lithium ion. In that case, so it works as a leverage between I would say the metal price of lithium carbonates. So I think sodium ion do have its a huge market and directions to go, and it's very interesting directions. And we are actually put quite a lot of efforts on study and also development of sodium ions, and we even already have the prototype products on that. And depends on the market whether or not it is demanded. We can basically decide whether or not to produce that. And we're also collaborating companies that is interested in sodium ions to do more development and also products in this directions as well.
Right. Yeah, I get a lot of people asking about what's next. People always love the new and the exciting, and so they ask about different chemistries. The other one I get asked about is solid state batteries. What do you think about the prospect of solid state batteries?
Oh yeah, I think solid state batteries is another really hot topics nowadays, and it's really a challenging stuff. I think from fundamental point of view, there's still quite a lot of different questions. I mean, difficult questions and then problems to be tackled, especially at engineering parts. So I think that's definitely a direction to go because we basically are funding new chemistries and new possibilities for the batteries. But still, between the lab research and fundamental research to the eventual mass production and application on the at product level, it still have a long way to go, especially for the engineering of the sodium ion, for solid state batteries. So I think that's the direction to go, and it's interesting, but we need to be very careful about its progress and also uh, whether or not eventually we can achieve that. I think it's still a place of doubt on that, but still I'm optimistic and very keen to do a lot of works on solid state batteries. And actually, in Morlus, we are having the R&D on solid state as well.
Yeah, cool. So you basically have taken products from pure R&D to commercialization. What are the challenges in that development cycle?
I think the challenge over here is that you may find a lot of interesting things and inspiring experiment results or R&D results in the lab scale. But when it comes to the engineering part, for the process part, for the anything you need for mass production, it normally comes with a lot of problems, and I think most of them are very challenging problems, and so that you don't see quite a lot of R&D results in the lab eventually became something on the product. So they transition between the R&D outcomes to the eventually the I think the results that you can actually embed it in your product is quite a long journey and difficult journey. The key over here is very strong engineering capability. So that's, I think, very vital to in this R&D circle. But I think majority of the people who actually are doing the R&D only have the background of the technical science or technical research background. They don't have the product experience. They don't have the experience that they're actually working on the production line. So to understand it from an engineering point of view, I think that is very important.
All right. So going from just pure lab to manufacture to actually having a product that you have to sell, there's a whole lot of different skill sets there. Hey, because you make battery systems that can work with other companies' PCS, or as we often refer to them in Australia, inverters. How does that integration process work?
Oh yeah. Basically, we make batteries, the DC blocks, and then if the customers have their special demand, then we will use their BMS. Otherwise, we'll have the preloaded BMS with our BMS supplier, and then we will hand over the BMS strategy to our collaborator. I mean, our customers, so they can take that strategy and then to be embedded with their PCS and the AC side. So that is the normal way we do so. Because we noticed that in different regions, especially in Europe, we have very strong compliance-free requirements in terms of the energy management system. So you have to use the localized energy management systems. And a lot of customers, they prefer to use their own BMS and EMS because they are more good at this, I would say, energy management system. They have a lot of experience. They have their own devices and hardwares and also software logics for that. So we're happy to work with them to use theirs in our product. So we're basically very flexible in providing the hardwares and also to use the software from the customers for eventually to be integrated over there.
So you can have your embedded BMS, but you could also have a third party, let's call it master BMS, that manages
Yes,
maybe more than one of your DC blocks,
yes,
and
exactly.
in conjunction with an energy management system as well, an EMS.
Yes, exactly.
And that's pretty cool.
Yeah, so it's
All
very
right.
simple solution. Yeah.
Yeah, especially when you've got very specific local requirements. Like here in Australia, we have dynamic export control
Yes.
in at least 3, soon 4 states in Australia. So that usually requires a third party to provide that service because it's very specific to each state and has to get approved. And it's easier if it's
Yeah.
done with a local agent.
Yeah, exactly. That's the situation that we face that when we are talking with different customers, each country has their own demand. Yeah.
Now, with your long history in energy storage and your experience, I guess you can sometimes think about where is the future going in terms of energy storage. What would your predictions be over, say, the next 5 to 10 years?
I think over the last 3, 4 years, I think yes, over the last 3 years, the entire battery industry has experienced a really rapid growth in terms of capacity and also in terms of demand of the market. And really have, so people may know that there's overcapacity here in China, uh, in the battery industry especially. But I still think that it is not enough for the global battery demand. Because what I mean it is not enough is that the quality, uh, I mean, the production capacity with very good quality is still in short. So in the future, I think for sure there will be a huge demand, and the quantity of demand will be exceeding our imagination at this point. If you look at the the IEA report, uh, every year they are basically relevant their predictions on the energy demand or renewable energy consumptions uh, at what scale. Uh, so I think in the next 5 to 10 years, for sure there will be more renewable energies. There will be more energy storage requirements that we possibly predict at this moment. And then the question will be, are we ready for supply really quality capacities to produce a robust and high quality product for the markets? Uh, so I think this is very important because the energy storage devices is basically an infrastructure that can support an energy transition in the future and also support now that is happening. So if we have really, I would say, robust and high quality stuff that can last really long, that has only that kind of product can be called infrastructures or can be called assets for the customers and for the energy transition. Otherwise, we are facing quite a lot of uh, fire hazard, safety challenge that may, I would say, slow down or postpone the passions about energy transition, and also cause loss of lives and also the asset. So I think that is something we need to bear in mind. So in the next 5 to 10 years, of course, I think there'll be more people coming to the energy industries, are paid a lot of, I would say, capitals and energies and people into this industry to create more, I would say, inspiring products for the demand. But in the same time, we should keep in mind that all the product need to be have high quality and then to be taking care its safety aspect and also to think about how the product can eventually support the energy transition rather than create a product that to sell. I think that's my vision towards next 5 to 10 years. There'll be a big driven force and also trend for the energy storage, but still we need to be careful and we need to be very diligent to work to make better products for the energy transition.
Yeah, I can certainly see here in Australia, utility storage is really making a big difference. With intermittent generation like wind and solar, we need lots of storage, but it's also proving to be the best source for frequency control and ancillary services, FCAS. We've seen batteries completely displace, well, not quite, but almost completely displace gas and coal, and or certainly gas as the solution to grid stability.
Yes.
So, but batteries are providing a service that almost no other technology can. Instant response.
Yes, exactly. And I also forgot to mention one important stuff is the recycling. With a lot of batteries to be placed in ground to work, and at the end of the life, we need to definitely to think about how we can efficiently and environmental friendly to cycle those batteries. That is also a very big challenge and also a really important direction we need to think about and also start to take actions.
I'm really glad you raised that because that is one of the questions I get a lot from consumers is what about end of life?
Mhm.
What's going to happen to these lithium batteries? So is that something that Morlus are looking into?
Yes, Morlus is very keen on the recycling as well. So at the starting of the company, we're thinking of the energy storage. We are not only thinking about the battery the cell and pack level, we're thinking from material level to the product level, and eventually to close the entire loop, which is the recycling. And currently on the market, people are doing quite a lot of recycling based on chemistry way to recycle it. But more or less are thinking differently. We're thinking whether or not it is possible to reduce the carbon footprint during the recycling process as well. And more importantly, we are thinking if there will be a direction to go that we can actually not recycle the batteries at the material level, but recycle the batteries with the materials what be used and to treat the materials and the chemistries for fit for certain applications, basically to elongate the lifetime of the battery that can be used. So basically to reduce the environmental hazard or impact. That is the direction we currently are working on. So for sure, we will come up with a ultimate closed loop solutions for the batteries we produce. That is also,
Wow.
yeah, the direction we think we need to go.
Okay, that's really, really encouraging. Thank you. Well, I've got one last question for you,
Yes.
Dr. Howe, because a lot of young engineers still at university or trainee engineers are watching my shows. What advice would you give to a young engineer or researcher entering the energy storage field?
Well, that's a really good question because I thinking about like I think 7, 8 years before I was still in university. I think at that time I don't know what kind of industry I'm going to go into and what will be for the stuff I've studied. And then nowadays, thinking back, what I think the most important thing is that for the engineering students working in this scenario, or not even they are not in the in this aspect. I mean, in this industry, the most important thing is that they have a really solid foundation of what they are studying at the moment. I think the most important part is the ability to learn, and also the fundamental understandings of the knowledge you get in the universities. And then with that, when you are going into industry, for example, like lithium batteries, you can learn really quick, and you will find in a lot of places what you have learned in the university is quite useful in the work. And I think the second important thing I would like to mention is that I think I already mentioned about it is very important to understand if there is a huge difference between the I would say industry R&D and also the I would say scientific research in universities. The quicker you can adapt yourself to the industry R&D to understand the logic of doing things in the industry R&D, the better you will do in this game, and also the more you will learn in the work experience. So I think that's two main suggestions I would like to give.
Wow. Well, thank you for providing that advice to young engineers. I'm sure there's going to be a lot of careers in energy storage going forward. So, Dr. Howe, thank you very much for being my
Very
guest
much.
on
Thank you,
Talk
Mark.
Tech.
Okay.
Now, I'm just going to do the outro. So just hang around once we finish the show, or we can have a bit of a chat. But otherwise, thank you very much.
Thank you very much.
Well, that was a really interesting discussion there, learning about everything from cell technology to cell packs, understanding the nexus between R&D and industry, what people actually need, and how you develop those solutions. So next week on Toolbox Tech Talk, I think DJ Glen will be back. You never know; he's a bit of a flighty one. But until then, look forward to seeing you all next Sunday, 1:00 Australian Eastern Standard Time. See ya.